Alright, so today we're doing 5.y, rate of change and slope. And the warm-up is, does the table represent the function? Remember, for a function, we only care about the x. And if it's repeated, it is not a function. And if it's not repeated, it is not a function. In this case, we have -2, 0, 2, and 4. So that means x is not repeated. So this is a function. So by the end of this lesson, you should be able to find rates of change and slopes and relate a constant rate of change to the slope of a line. The words you're going to be hearing constantly is rate of change, rise, run, and slope. As we go through the lesson, I will be explaining what each one means, but just want you guys to be aware of the words. So the first one, a rate of change is a ratio that compares the amount of change in the dependent variable and the amount of change in the independent variable. The rate of change equals change independent over change of independent. Now remember, the independent variable is always the x when it comes to an equation like we have seen before. Like this would be the independent, and the dependent variable is the y. Now, how do you figure out which is the dependent and which is the independent? The independent, guys, is the one that can change no matter what. So, for example, you've had in a previous homework and previous things an example of soap and water. You would say you add a cup of water for every half a cup of soap, for example. So in this case, the soap will be the independent variable because you add the water depending on how much soap you put in. So you put a half a cup of soap, you put it in 1 cup of water. You put 1 cup of soap, you will put 2 cups of water. So the dependent depends on the independent, so it's in the name. But if you ever have a doubt, think about it. Which one changes based on the other? If all of the connected segments have the same rate of change, then they all have the same steepness, and together form a straight line. The constant rate of change of a line is called the slope of the line. So you guys remember, we've seen linear functions, stuff like this. That's a linear function, drawn to the best of my abilities. The slope would be how much the difference is from this point right here to this point right here. So that will be the slope. We'll figure out how to solve the slope in 1 or 2 more slides. But I want you to understand the slope is a constant thing, whether it's a linear function or not. But as of right now, we're only going to deal with linear functions. The other ones are quadratic and other stuff that we're not going to talk about right now. Just remember, the slope is the constant change, and then you connect those points to make a straight line or a linear function. We learned that in the last chapter. So here we have how to get the slope of a line graphically. So the rise is the difference in the y values of 2 points on a line. And the run is the difference of the x values of 2 points on a line. So the slope of a line is the ratio. Remember, ratio means division, guys. Of rise to run for any 2 points on the line. So we have the slope equals rise over run, or the change in y over the change in x. And it says, remember, the y is a dependent variable and the x is independent. We just said that. So for example, let's actually work this out. We have this point right here. That point is 0, -1. And we have this point right here. That point is 2, 2. Correct? Now, how do we figure out the slope? Well, remember when you're going in a coordinate plane, this is the positive y. This is the positive x, this is the negative x, and this is the negative y, right? So if you move vertically up, you're going to get a positive slope. But if you move to the left, up and left, you're going to get negative. Up and right is going to be positive. Down and left is going to be negative, and down and right is going to be, down and left is going to be positive, and down and right where it's going to be negative. The reason it's going to be negative, even if you go in 2 negative directions, is because they say it's a fraction. So if we have the y over the x and they're both negative, that's going to simplify to a positive. That's why it's going to be positive if you go up to the right or down and to the left. And then up left is going to be negative and down right is going to be negative. But let's do it based on this graph. So we start at this point, let's say. And we're going to go up the y-axis. So 1, 2, 3. So we get the change in y to be 3. And then we're going to see how much we go on the x-axis. So from this point right here, we're going to go 1, 2. We're going to put a 2 right there. Now remember, it's the change in y over the change of x. So the y value always goes on the top. Doesn't matter what point you choose, it will be the same. If we go down, for example, from this point, go 1, 2, 3, we're going to get negative 3. And then for the x, we're going to go from this point 1, 2. We're going to go negative 2 because we're going down and left. Now, miraculously, negative over a negative in a fraction simplifies to a positive, so we're left with 3 over 2 as well, giving us the same answer. So it doesn't matter from what point you start, as long as you put the change in the y correctly and the change in the x correctly, you will get the same answer. Now this is just an example, and you can start at any point in the graph. I just like starting closer to the origin because it makes it easier, they're smaller numbers. But you can do whatever points in the graph and you will get the same thing. So they want us to find the slope of this line. So they're telling us to first begin at one point and count vertically up or down to find the rise. And then we count horizontally left or right to find the second point. And that would be the run. So again, this is just stating what I just said. It does not matter which point you start with. The slope is the same. So let's write in. It's going to be changing y over changing x. If we have negative 6, comma 5, and then we have 3, comma 2, so right here, negative 6, comma 5 right here. Let's count it. Let's start from the farthest left point. So we're gonna go 1, 2, 3. So we went down 3. So the change in y was down 3, so it becomes negative. And then let's see how much it is towards the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. So since we're going in the positive direction, remember this is positive x, we're going to put in a positive number. Now your slope is negative 3 over 9, but this needs to be simplified to negative 1 over 3. The reason you simplify it is because that will be the next closest point. If we actually run negative 1 over 3, we're going to do negative 1 and then 1, 2, 3 on the graph. Look, we hit the following point. Negative 1, 1, 2, 3. We got another point. Negative 1, 1, 2, 3. We got the same point. Negative 1, 1, 2, 3. So as long as you're able to follow it, even if you simplify it, you guys chose different numbers in the graph. If you simplify it, you will get the same slope. As you see, I just went all through it out the points in green based on the simplified slope. But if we go from the original point, from the right to the left, then we go up 1, 2, 3. We go up 3, so it's going to be a change of positive 3. And then we go 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left, so it becomes negative 9. Simplify, we're left again with negative 1 over 3. So we get the same number. Now, I want you guys to realize, when we went in the color black, down 3 and then to the right 9, we put the 3 as a negative, and when we went in the red and we went up 3 and left 9, we put the negative 9 as a negative number. I want you guys to realize it doesn't matter which number is the negative one. That's why when I simplified it, I put the negative in front of the fraction. As I show you, it doesn't matter what way you go. If you go in the correct direction, you will get the same answer. So it doesn't matter which way you go, and the negative is either the top or the bottom number. It really doesn't matter. So please don't get stuck up in if it's a negative 9 or if it's a negative 3. It's fine. It doesn't matter. Either number is fine as long as there's only one negative, because 2 negatives simplifies to a positive. Everybody okay with this? So for the example, they want us to find the slope of a line that contains 0, negative 3. So this point right here, let me do it in a different color. This point right here, and 5, negative 5, so this point right here. So to find the slope, again, it doesn't matter what point we go with. I'm just going to go from the 0, -3, and then we'll go the other way just to go over it. We go down 1, 2, so the change in the y, over 1, 2, 3, 4, 5 on the x. Now that fraction is already simplified, so that's it. You guys found the slope of that line. If you would have done it from the other point and you go 1, 2 up, and then 1, 2, 3, 4, 5 to the left, you get 2 over -5. Again, this is the same thing, guys. So you would have been correct no matter which way you went. And just to show you guys that the graph can keep going in the same format, I'm going to keep going the way the blue line went, up 2, and then down 5. 1, 2, 3, 4, 5. And look, we landed a new point on the graph. So you can do that to graph. You can just keep counting 2 up and 5 to the left, or 2 down and 5 to the right. And you should be able to just keep graphing this line forever. Now, obviously, I'm going to stop in this one because there's no more points for us to graph. But I just want to show you that you can keep going. And this is a very valid point. That is a point in the graph. So to find the slope of the horizontal and vertical lines, it's a little bit different. It's still the rise over run. So the change in y over, let me do a different color. The change in y over the change in x. So y, x, the change in y over the change in x. Now, in a vertical line, we can go up 1, 2, 3, 4, 5, 6. And you guys notice there's no change in the x, right? So that would be 0. Now, anything, a fraction that has a 0 denominator, guys, in any calculator, in any ever, like forever and ever, it's always going to give you an undefined or an error in the calculator. So if it has a 0 at the bottom of the fraction, it's undefined. Now, it says it right here too, the slope is undefined. Now for b, which is a horizontal line, we notice there's absolutely no way we can go up or down in this fraction, in this function. So we're going to write 0. And then the change in x, we can go, well, 1, 2, 3, 4, 5, 6 to the right, or 6 to the left. Doesn't matter. 0 over any number is 0. Simplifies to 0. You guys can try it out in any calculator. 0 divided by any number. You can put a million, whatever number you want, and it will always be 0. So 0 over any number, that's why it doesn't matter if it's positive or negative, will be 0. So the slope is 0. Now, the way, when I was in school, I learned it thinking about it this way. So, the way my teacher explained it when I went to school, they drew a little mountain like that. And you can pretend this guy's hiking. If he can go up the mountain, you have a slope. In this case, it will be positive. If he's going flat on the mountain, you have a slope, which is 0. If he's going down the mountain, that's a negative slope. And if he's just free falling off the cliff because there's no way you can go up and down vertically on a hike, that means it's undefined. So if that helps you figure out if it's a positive or negative slope, that's always going to be the case. Going up the mountain, the way this drawing is made, is always going to be positive. And the flat part is always going to be 0. Going down the mountain, based on this diagram I just made, it's going to be negative. And if you fall off the cliff, it's undefined. I still remember that to this day. And when I saw this, I was probably around your age, guys. So it might help you. Remember, this is a vertical and a horizontal. You guys don't have to actually do the change if you remember the diagram from the previous page. Or if you just memorize what a vertical slope is and a horizontal one is. It's always going to be the same. So for the vertical slope, you guys remember the little guy, that's when he's falling off the cliff. So that would be undefined. And then for the horizontal one, that's when he's walking flat. That is 0. Now, if you forget the drawing and you just don't remember, you're having a hard time memorizing, go ahead and find the difference. If you go 1, 2, 3, 4, 5, 6, 7, 8, it's rising 8 and it's running 0 because you're not going anywhere from left to right. And a fraction that has a denominator of 0, again, always gives you an error on the calculator. It's undefined. So you can always do it that way as well. And same for the horizontal. There's nowhere we can go up or down, so you can't rise up or down, and you can only run 4 different way. From 4, I'm just running from 2 points, so 4. So 0 over any number is 4. That's 0, sorry. So 0 over any number is 0. In this case, it's 4. In the other one, it was 6. It could be positive or negative, and it's still going to be 0. So if you don't memorize the slope for these two, and if you don't like the drawing and you like to work it out, by all means, go for it. Just remember, 0 at the bottom is undefined, and 0 at the top is okay. So 0 at the bottom is not good to go. 0 on the top is good. So in this slide, as shown in the previous examples, slopes can be positive, negative, 0, or undefined. So you can tell which of these is the case just by looking at the graph. So if you look at the graph of a line, you don't need to calculate the slope. So you'll know if it's positive or negative, and you might just have to find the difference, whether that be to the actual slope, but you'll be able to tell if it's positive or negative. Again, if you guys remember the little drawing of the mountain, the positive slope is the one when he's going up the mountain. The flat is the 0, the horizontal line. Going down is going to be the negative. And then if he falls off the cliff, it's undefined. So if this also helps because it's always going to be true, the drawing. Now, if you don't like it, that's fine. It's up to you if you're going to use it or not. It's just a tool because climbing usually means you're going up the hill. When you are in a flat land, you're not going up or down, so it's 0. When you're going down the hill, you're usually descending, so that should be negative. Or that's a correlation, at least I give it in my brain. And if you fall, there's no floor, so it's undefined. It's a vertical line. So for A and B, they want us to tell whether this line is positive, negative, 0, or undefined. So I'm just going to draw my little mountain guy. It's positive, 0, minus, undefined. Since that's all they're asking, I'm going to draw the whole guy, but you don't need to if you don't have to draw the stick figure if you don't need to. So if we compare A to our little guy drawing, we see it's going up the hill, so this is a positive slope. Now we look at B, we notice he's going down the hill. It's not a very steep hill, but he's going down, so this would be a negative slope. And if you're ever in doubt, you can always find the slope. If you notice, let's say I'm gonna do this point. I'm gonna rise 1 and run 1. So we get a positive 1 over 1, so it's positive. Here I am going to, you can't really draw it, but if you notice, I'm just gonna go down 1, and then I'm gonna run 1, 2, 3, 4. It's gonna be a positive X number, it's just not in the graph. So negative over positive is negative, so that's where you also get the negative slope. A bigger graph is easier to mark 2 points. In this case, you notice either go up and to the left or down and to the right, and that will be negative. Again, they want us to tell whether the slope of each line is positive, negative, 0, or undefined. So I'm gonna draw it without the actual guy, just to have a little mountain just as a reference. We have the vertical line for A, and that is undefined. That's where the little guy falls off the mountain. And then for B, we notice is going up and to the right in the same direction as our uphill mountain. So this would be a positive slope. Let's do these 2 problems. So we're going to use rise over run. I'm going to start on the further left one just because. So I'm going to go down 1, down 2, so the Y first, over, then 1, 2, 3, 4, 5, 6. That's going to simplify to negative 1 over 3. Let's see if it's the same way if we do negative 1 over 3. Let's see where we land. So negative 1, and then 1, 2, 3, right on the point. Negative 1, 1, 2, 3, right on the point. Awesome. We know we got it right. We can go the other way, and we'll get the exact same thing. Up 3, and then 1, 2, 3, right on the point. Up 1, 1, 2, 3, right on the point. Awesome. We did that great. Now, for the second problem, now we know this is a vertical line. We can still try to figure out 2 points if you don't remember this is undefined. We rise 1, let's say we rise 2, and we run 0. Again, the x being on the bottom is not good, so we will say that is an undefined slope. So undefined. All right, since there are no questions, you guys, the homework is posted on Canvas, and you do have homework. The homework is due Monday.